In the last video, we took our first dive into generative AI models. But today, let's explore how they fit into broader machine learning ecosystem. Traditionally, many machine learning models are called discriminative models. These models focus on answering questions that have fixed answers, such as determining whether an image is a cat or a dog. We train this model using label data, which they become capable of recommending categories or making predictions based on new input. But their ability ends there. A discriminative model can analyze data, categorize it, and even give us predictions with some level of certainty. Let's take a different example. We want to train a model to classify images of cat and dog. To do this, we have provide label images, pictures clearly marked as either a cat or a dog. In a real world scenario, we might need trillions of images to train the model accurately. But for now, we will keep it simple with smaller dataset. If we have trained our model with enough data, it can confidently make prediction when shown a new image. For instance, it can tell whether a picture is a cat or dog. But that's all it can do with a certain degree of confidence. Now, generative model turns this idea on its head. Instead of just categorizing images, they can generate new content based on what they have learned from training data. They imagine, for instance, if you ask a generative model for a picture of a dog, it can create a completely new image that looks like a dog. Even enough, it is never seen that exact dog before. Pretty amazing, right? What even more interesting is that generative AI can integrate both discriminative and generative models along with other statistical techniques. But it is not as simple as mashing them together. These models work together like part of a finely tuned machine to create the best results. When done right, the creative output is astonishing, like what we have seen in earlier example. One of the most exciting example of this synergy is the Generative Adversarial Network or GAN. In GAN, two models, discriminator and generator, compete against each other. The generator create images while discriminator try to guess whether they are real or fake. This back and forth helps both models get better at their task over time. For example, the generator might try to create an image that looks like a dog but has some cat-like characteristics. These discriminators then try to guess if it is a cat or a dog. After several rounds, both models become extremely good at their task, to the point where the generated image becomes incredibly convincing. Unlike current AI, AGI would have the ability to reason across different domains, think creatively, and exhibit human-like intelligence. It could interact socially, understand languages, and even see and interpret the world, just like we do. AGI can then solve problems that are typically reserved for humans. Now that we understand the difference between discriminative model, generative AI, and AGI, it's important to use the right tool for the right job. Discriminative models are perfect for predicting things like the weather or categorizing images. Generative AI, on the other hand, is great for creating new content, whether it is writing code, generating response, or even creating art. AGI, whether it's come, will go far beyond this, tackling more complex tasks.